Hello, hello, hello. Welcome back to another stream. I'm just eating food right now. Hence the chewing sound. I woke up at 5 a.m. today. It was crazy. My cats were chewing my hair. Sorry, I gotta take another swig of water. All right. I'll wait for people to get in and then I'll talk about what I've been working on. But, whatever. What's up, Doru? How you doing? We Newton? Oh, we're always Newton. We're working on, oh, actually, I forgot to change my title, didn't I? We'll still have the cat cam, but today is network optimizations. It's a network optimization sort of day. Yep. Yep. I've been working on trying to improve how the interpolation works, so just it's more smooth on high lag situations. I have it set to high lag right now. I think I have a, this might work. You can kind of see where it's at right now. What it should be doing is it should be like, this is pretty smooth. The only downside with how I've done it is that this might drift too far away from where I am. I'm constantly interpolating to some point, but if I keep going straight, he moves slower than those move. So what ends up happening is if I turn, he'll catch up because he can short circuit things a little bit. But if I just go straight for a long time, he'll just keep getting further and further away. I also turned off client predictions, so that's why he's so far behind. But ideally, he'd be pretty close to where he should be, or where it says he is on the server. But I'll talk a little bit more about how I did this. But I'm trying to figure out the best way to do my like interpolation so that he stays in the right spot the whole time. Like you can kind of see, there'll be a packet dropped and then there'll be a big skip. Like there was a big skip. I'll wait for another one. Okay, not there. But eventually you'll see packets get dropped and there'll be a bunch of packets at the end. It'll kind of be a big hop. So the objective is to, if that happens, so the reason you stay far behind is so that if there is a big hitch like that, it doesn't affect what the player sees. The player doesn't notice that stuff because we're replaying the game in like a past state. We're kind of like constantly putting more frames in front of him to replay. So that way, if like, let's say we have 3 frames in front of them and we want to, and there's a big hitch that takes 3 frames to get resolved by the next packet, then we'll replay those 3 frames, and hopefully by that time, the next frames will have come in. And then we can have those to replay. So that's the general idea. So you end up playing them in the past just so like it smooths stuff out. But how I'm doing interpolation, there's a lot of commented code here. I've been doing a lot of stuff, or there's been a lot of attempts. I'll say that. Um, but how I do the interpolation right now is, well, this is technically not the right speed. That's why it's running slower. 200 times dt, the fixed time step, should be the right speed. So what I'm doing is I'm basically saying, like, there's the, where is it? I calculate delta, which comes from the interp2 position. So there's a place we're going to, and there's the place we currently are. And we basically make a movement vector in that direction. We calculate the delta, we normalize it, and then we scale it by the speed. So you can kind of imagine that, what that looks like. It looks like we have the place we want to go to, we have where we are. We have like a normalized vector there, and then we just scale it by how fast we can move in that direction. And the only weird thing that I don't know why it's happening is that if I have my speed at this, you can kind of see what happens. This is the appropriate speed. Or let me turn debug on. He ends up catching up and then stopping. So he's getting there too fast. So it's like this weird balance, but where I don't want to go too fast and I don't want to go too slow. It needs to be just right. What I was thinking of doing is, instead of using speed, I would use like an actual interpolation, like a linear interpolation. But this didn't seem to work very well. That's kind of where I stopped. Comment this out. I'll also need to add the interp package back, which has all my interpolation stuff in it. Now it kind of does this like speed up, slow down thing, which is really weird. But at least he's not stopping. There's a few skips. I think that's happening because the time it takes me to interpolate between positions isn't being set correctly. I need to calculate that properly, which is this total. And it's like a dynamic thing though, and the distance is also dynamic, so it's kind of a weird problem. I'm not really sure exactly how to resolve it yet, so we'll be thinking about that today. I wish I could say I had a plan. This was kind of what I wrote yesterday. I should track per tick delay times and use that to determine how long I should interpolate for. Let me draw this out. What ends up happening is there's the positions you're moving between. This would be like if there was no packets dropped. So when we have that, we can interpolate perfectly, right? We want to move from here to here. Like these come every like 16 milliseconds or so. Every packet does. So packet 1, packet 2, and these are different positions, let's say. So then what's going to happen? Let's say that we get this one on, this is on the client now. This would be like perfect. We have client. I don't really know how to diagram this stuff other than like timelines like this. Let's say we get this packet, and then we get let's say we drop this packet. So then we get this packet here. So this one gets dropped. So now you have this big distance, but it looks like it's 1 tick to us, but it's far away. I almost need to calculate like it's weird because I almost need to know the speed that I should be moving at, and I need to move at that speed. And the speed should match up with the time. I just don't know I don't know why this Right, so a packet gets dropped. And then we end up interpolating to this one. So it's like we're somewhere like in between here. And then we interpolate all the way to here. This third packet. Because we have like I have a timer which pops these off basically. So that's one, I guess that's one problem, is if packets get dropped, I might be popping them off too fast. And if they are too... If they're too slow though, like if it's too slow, that's actually not that big of a problem, because what I can do is I can just pull off more packets. I just feel like the interpolation is the right way to go about this. The weird thing is I just don't know the time. Like this is, it should be around 16 milliseconds, but there's also like jitter now. So some of these might be longer and some of them might be shorter. They should be interpolated inside of, I guess they should be interpolated inside of this average tick time. I don't know if you can hear my cats running around. A bunch of wild creatures. Let me think here. Let me look at what did I do for popping, because I have a queue. How it basically works is I have a queue that takes off. Where is it? Like I have my timer. This is basically a timer. Or no, sorry, this is a timer. We subtract the DT. If it's gone below 0, then we remove the next one. If there was one to remove, then we can start interpolating to that one. If there wasn't one to remove, then that's kind of a problem. And right now I just print it out. That would mean that we're like reading them too quickly, which is mostly the case right now. So we remove it. Oh, that's why it rubber bands so much, because what I was thinking of doing was that if you get, like, you have this replay buffer, or it's not really a replay buffer, but you have this queue, and let's say you're like 1, 2, 3, and then this is what's in your queue. Well, I guess you would be reading this one, and you'd be writing here. That's your read, that's your write pointer inside of this queue. But so you'd be reading the tick 1. That would be like, I guess technically you would have already read that if we're in this situation, but 2 got dropped. So you should be reading here, tick 3. But what I did was I basically measured the length of the queue, the length of the elements in the queue. And if it gets below my target number, which right now I have it set to 3, target delay, which this could be dynamically configured though, depending on your ping, or sorry, depending on the jitter, the spikes that you get. If you get really big lag spikes, then it'd be important to have a higher number here. But if you have really consistent connection, having a higher number here doesn't matter. And we could probably be fine with just like 1 or something like that. But target delay, yeah, so we basically find the length. We subtract, like, this is 3, let's say. So 3 minus the length. So that the length is 2, we're going to scale up the tick time by 2. So that means instead of like this would, if length is 3, then we would use DT. If it's 2, then we use 2 times DT. Because, oh wait, actually it would be also DT. Wait a second. Is that right? Target delay 3 minus 2 would be 1. So I guess this would be dt as well. 1 would be 3 minus 1, which is 2, times dt. So this would end up scaling. This ends up scaling the interpolation time by 2. Like the time that we wait before we pop the next tick off. So like it hopefully gives us more time. What that ends up causing is it ends up causing that rubber banding, I think, when I do the interpolation mode. I could also just capture the average tick time, like do a trailing average or something like that. And then it'd probably be smoother, because right now jumping to 2 times the delta time, that's going to make like this third move. Well, like let's say that 2 didn't get dropped, it would make this third move, but like 4 gets dropped or something like that. This 2 to 3 move is going to take twice as long. So you end up going really slow, and then you go fast again. So you want it to go slow, but not like that slow. Because ideally, by the time it gets there, the next packet should be already in. But it's almost like a controls problem, right? It's like you need to make it so that you're waiting the right amount of time before the next thing comes in. What's up, Piece It? How's it going? I subbed after watching one video of yours. Nice. Which one? Was it the Rust one? The Rust First Go physics one? That seems to be my my most popular at this point. Yeah, the Rust one. Cool. I hope you liked it. Took a long time to put together, but I think it turned out okay. Yeah, that one's really doing well. I think I might get 100K views on it. That'd be my first to do 100K, which would be pretty cool. Yeah, it was great. Well done. Thank you. I appreciate that. Yeah, I'm always a little scared. I'm a little scared and reluctant to like post benchmarking videos because there's always the possibility that like I make some big mistake and it's like just invalidates all of my stuff. But so far, I think that one hasn't been too like contested, so I'm happy about that at least. It was kind of hard though because I don't know Rust super well, so I was more worried in that area that I was going to be doing something that was completely wrong. But I think it was fine. I'm not really sure. I'm not really sure a good strategy here. I'm a junior Go dev, and I think I can learn a lot from you. Oh, cool. Yeah, I don't know how experienced I am in Go, or I've never professionally done Go before, so I probably do some non-standard things. So you can be on the lookout for those if you want. But I do like the like Go way of doing things though. Most of the time, there's a few things in Go that I wish were slightly different, which well, at least it would make my life easier. But I think for the greater Go community, it probably wouldn't make things that much better. Like most people don't care about performance as much as I probably do, because most people aren't doing video games; they're doing like web services. But I think is the target Go thing, right? What's your opinion on error handling in Go? I used to think that it was actually. I used to think that it was pretty good until I had to do Yeah, most people don't like error not equal to nil. Yeah, I don't mind that so much. I feel like you like Rust has that question mark operator, right? That you can put at the end of a statement, and then what that'll do is if it's an error, or if because there's an error type in Rust, if it's an error type, if it's like in the error mode of that algebraic data type, then what will happen is it'll return. It's like the equivalent of doing like if error not equal to nil, return error. Like the question mark operator just translates to this code block. What's up, Dracula? How you doing today? Which like something like this might be nice. I personally don't really mind typing this out every time though. Adding things like this are nice, but they're one of those things. It's like another language feature that people have to know about, you know? It ends up being like, what can happen? I'm not saying Rust necessarily has this problem, but C++ definitely does. What can happen is that you end up bloating your language spec so much that like you look at anybody's code and it looks completely different just because they use different language features. I think this is a pretty like genuine one though. This might be reasonable to add to Go just because it's a common pattern. The problem becomes though, like, what if you have like a slightly different thing? Like if you have multiple return types now, this becomes kind of tricky to do. Or you want to add like some extra thing inside of here. But at the end of the day, in Rust, you have to do the equivalent of this. You just do it in a match expression rather than an if statement. So I don't think that, unless Go wants to add in enum types or algebraic data types, whatever you want to call them, and then unless Go wants to add those in and then have some static compile check that forces you to unravel your algebraic data types like the match statement in Rust, then I don't see any improvement on this pattern specifically. But one of the problems I do have with the error handling in Go is like an error is just a string, which makes it kind of tricky to I find it hard and confusing to like what determines a new error, if that makes sense. Like because you can make your own errors with like error or format.errorf, and it makes it hard to like if I want to wrap an error, I kind of would hope that it would like build some error stack or something like that and return all of those up, but I don't think it does that. I think when you wrap an error, all it ends up doing is it appends like the previous error string on top of your error string. And that part's tricky for me because if you want to compare an error, if you want to wrap your error in something like a new error type that you have, but you want to enclose some other error thing, you have to like build a new struct for that and you have to like type it and stuff like that. It would be nice if there's some implicit way of doing that, which I don't think it's in, like, I think if I could probably make a package that does it for me. But that was one thing I don't like that much about error handling in Go. That's my big problem, I think. Because it's hard to know like what's the same error. Is the same error, like if I wrap, I guess I don't really know, I'm not 100% sure how they do error comparisons, but what I understand is just comparing the string. So if you make a slightly different string, yeah, explicit wrap message, yeah, I should look into that more. I'm using just the regular errors package, but I've only had to do it once, but it was kind of like, it was hard to understand. I guess I'm kind of curious now what I'm kind of curious. I gotta leave for 3 minutes. No problem. This is archived. I wonder why they archived it. I wish they would say. They might have added these functions to the errors package. I know there's unwrap. Yeah, see, this is the weird part. You call like format.errorf and apply the %w verb, and that's how you wrap an error. This is wrapping this error message inside of this one, But then does this error, like, is this its own unique error? Is unwraps the first argument sequentially looking? See, I don't understand how they could possibly unwrap this though. Unwraps the first argument sequentially looking for an error that matches the second. It reports whether it finds a match. It should be used in preference. Simple equality checks. As unwrap, yeah, maybe I should have just read this. As unwraps, it's first. As unwraps, it's first. Oh, as the function as. I was like, I don't know how to read this sentence. As unwraps the first argument sequentially, looking for an error that can be assigned to the second argument, which must be a pointer. If it succeeds, performs. See, I don't know. I wonder how this works. Unwrap returns the result of calling unwrap on error. If error's type contains an unwrap method returning an error. Oh, maybe oh, so an error is just something that implements this interface. So you have to make a function. So I guess when you call error f, format error f, where is it? So we're just looking at it. Oh, here it is. I guess if you do format.error f, then when you create this one, you pass in this error to it. You could probably only have one error, I guess. And what it'll do is it'll create a function as well. It'll create an error object here, and it'll create an unwrap function for it that returns this underlying error. So you can unwrap them that way, I guess. So you end up having maybe like an error stack. I guess that's okay. I think I just didn't understand this earlier. That seems fine to me. I don't know. It seems weird that it's just one string. I don't know. I feel like I might prefer errors if they were just like a stack. Like the data structure was just a stack. That seems easier to manage, like a stack of errors strings or something. Then you're not like creating dynamic strings like this. That's the part that confused me. Because I thought that all this did was just check to see if it was the same. But anyways, I probably would write a wrap function. It seems weird that you have to do format.errorf rather than like calling a wrap function. That seems strange to me, but I think I'd prefer just having a wrap function. That would make it easier for me to think about, I think. But oh well, I guess it doesn't matter that much. Let's see. Okay. So where we are right now is as network, here, let me make a new document. Maybe I need to explain this out loud and then it'll help me understand my problem. We have ticks coming over the network. These are going to the client. And the client creates a buffer. And then the buffer gets replayed. Welcome back. Oh, I figured out the error thing that we talked about. I guess you can go back and replay it if you want, but I think the complaint I had originally about errors was just me not understanding how they were supposed to work. So I guess I'm generally fine with Go's error handling. I don't think there's really anything that much better than it. Like I can't think of a system, or at least maybe I don't know of a system, but I can't think of a language that has like that much better of error handling. It might have some nice like syntactic things that make it easier, but the general premise I think is pretty much the same for most languages that do value-based error handling. And by that I mean like not the languages that do exceptions for errors. Hmm. Okay. So maybe we'll make columns of a timeline of how things come in. Or we'll do another column here, which is like the server. This is like the game server. This will be good, I think. I like the default way of wrapping errors in Go. Yeah, I think it would be nice to have a wrap method. I probably would write, I don't know. It seems weird to write a wrapper around the errors package, but I might wrap that just so I can have like a wrap method. What game will it be? Well, this is an MMO. I don't have too much. I don't have too much in terms of like game design, specific game design elements planned. I have like a general idea of what I'm building, but mostly I'm trying to get the I might be able to just run it for you really quickly. If you're curious to see. The ignore the jittering. That's what we're fixing right now. But this is where it is right now. We basically have this little island that you live on. Or I'll do this. You can go here. And this is the current state of the game. If you're international, then you'll probably have a lot of hitching, and that's what I'm trying to fix right now, is high lag. When you have high lag, I want it to be a little bit smoother. You can do /debug, and you can see your ping. So you can see I'm like 89 max ping, and mine's pretty smooth. You can hit enter if you want to type something. Hello. Hi. Senior Design is doing a new error library for almost every project. Interesting. We damn boys. What up? This is cool. Thank you. Yeah. I pretty much streamed most of the development of this, so you can look through my massive stream catalog, starting around like 40, I think stream number 45. Even on mine, there's a little bit of hiccups, and those are caused by jitter. But it's pretty responsive. It's responsive because I do client prediction. So the client predicts where you're going and moves you there immediately, and then the server tries to catch up with where the client says, or with where the client is predicting you to be. Yeah. So it's gonna be some top-down thing like this where you do like combat with things. So maybe somewhat inspired by Realm of the Mad God if you've ever played that one. It'll probably be similar to that. It'll probably be less of a bullet hell though. And you have to Google how to find a function every time. This do be cool. Thank you. Yeah, it's pretty good. If you're on high ping too, what can happen? There's a few stability issues. But this is all in Go, and then I compile it to WebAssembly. And that's why it runs in your browser. This do be cool indeed. Thank you, Mr. Task. Welcome to the stream. Yeah, if you walk on the water, you go a little slower. Yeah, it hitches. Well, so there's actually like kind of a long explanation to that, and I can go into it. But basically what happens is on browsers, you have to use WebSockets. Well, there's multiple networking things you can do on browsers, but WebSockets is like the most stable one. There's also WebRTC, which gives you UDP, but WebSockets runs on TCP, and that's what I'm using. And how TCP works is TCP guarantees that every message is going to come in, is going to arrive sequentially. So what can happen here? Let me do a little drawing here. Or what you can have in TCP is you can have like, let's say you have the stream. Basically, TCP is a stream, and then it gets chunked up like this, and it's kind of arbitrary. But let's say that like this is chunk 1, that's chunk 2, that's chunk 3, that's chunk 4. These get individually packetized and sent over the IP network, right? And TCP is the protocol on top of that, and it's the most common one as well. So what can happen though, because TCP, this is what's sent. Then on the receive side, we get the chunks, but they are not necessarily in the same order. And also you can have packet loss, which means some things can get dropped. So let's say what ends up happening on the receive side, you get packet 1, but then packet 2 gets dropped somewhere, and then you get 3 and 4. When I read this, on a TCP connection, when I read this, I'm forced to read it exactly like this. So I'll read 1. I'll read the first chunk, which is 1. Then it's going to pause. Even though 3 and 4, or sorry, this is supposed to be packet 2 comes in. It's going to pause all the way until 2 comes in. And then I'm going to get 2, 3, and 4 all together. So once 2 arrives, it's going to give me 3 and 4, even though it had those all along. I guess we can make this red. But this is how my read is going to look. It's going to have a big delay in it. So that's why you get hitching, because the client is like, oh, he's over here. And then there's a big pause. And then it's like, oh, actually, he's like here. He ran here, here. This is like 1. And there's a big delay. And then it goes 2, 3, 4. And by this time, the only important piece of data is the 4 part. So that's why people use UDP, because if there's a packet that gets dropped, I'll immediately get 3 and 4. So in UDP, what I would have is I'd get 1. Then there would be a pause because 2 got dropped. But then I'd get 3 and 4. As long as those don't get dropped. Sorry for my terrible drawings. But so 2 got dropped, right? So we don't have 2 anymore. So there's delay from 1 to 3, but 3 came in time. So we got 3. So that's why people mostly use UDP. And because the packet got dropped for 2, that means I have to, that TCP has to resend 2. And there's a bunch of like back and forths of the server and client, like, hey, did you get this? Like, did you get my packet? And he's like, no, I didn't. This is supposed to be a no. No. Then he resends it. And then on this resend, if it gets dropped again, he's gonna slow down his resend. It's called exponential backoff. So he's gonna slowly send the next packet. Then he's gonna say, hey, did you get it again? And he's gonna be like, no, I didn't. Then it's like this long chain of bouncing back and forth. But the reason people use TCP is because of the guarantee of like a perfect stream of data. So, but yeah, that's why. So today, what we are coding is, well, yeah, that does make sense. I hope it makes sense at least. But what you end up doing because of this jitter problem, here, maybe I can describe the problem a little bit better. What you end up doing because of this jitter problem, good, I'm glad. What you end up doing because of this jitter problem is you will, you're basically gonna buffer the packets, or I can draw it down here probably. You're gonna buffer the packets. Like I'm gonna wait until I have 3 packets, and then I'm gonna start playing them. So I'm gonna have like 1, 2, and 3, and then I'm gonna start playing like 1 to 2, in hopes that by the time I get there, 4 has already come in. And then I'm gonna play 2 to 3, and by the hopes I get there, 5 comes in. And what can happen is like, it's almost like that picture, you know that picture where like the guy's laying railroads like right in front of the guy. It's like Bugs Bunny or something. Placing railroad in front of train. Cartoon. It's like this. It's like this is the exact thing. So you're trying to like keep the packets in front of you so you can replay them. That's kind of the objective of how you solve this problem. So if there's a big jitter, we might actually get to here, and then you run out of railroad track to run onto, you know? But if you keep a longer buffer, the downside is that, like, you know, the server told you that you're over here at tick 8, but you're still replaying far back, you know? But the benefit is that if tick 9 takes a really long time to get there, you might have a little bit of time to wait before tick 9 like finally comes in. And you get 9, you know? That's kind of that's the strategy. And then you can also, this is called interpolation. And then you can also extrapolate your position based off of what the client knows about the simulation, and what you can kind of extrapolate a point. So you can kind of like guesstimate where you should be, but I think that those are a little bit less stable usually, because the client's doing his best estimate of where he should be going next, but isn't really sure. What's up, Jomi? How you doing today? Nuding morning. But anyways, that's kind of the problem. That's the problem we're trying to solve. Is that how Minecraft does it? I don't know how Minecraft does it. They might have Valorant does something similar, but instead the client increases its buffer to accommodate more packets. Yeah, so you could probably dynamically change your buffer based off of how much lag you have, or how big your ping spikes are. Because you can have high lag, but you could have a high lag, but you could have a high lag, but still, I forgot. I lost my train of thought. Sorry. Minecraft is the only popular game that uses TCP I know of. Oh yeah, that's what I was gonna Google. Minecraft network model. There's really like there's two Java one. This is a good if you guys want to learn about video game networking, you should read this one. But there's really like there's two things you can do, it seems like, from what I understand. Well, there's three things. You can, and two of them are kind of similar, I guess. You can hold a replay buffer of old data and then replay that, and that reduces hitching but makes the lag even worse technically. You can extrapolate. This is like commonly referred to as interpolate. You can extrapolate, and that's where you like predict. That's where you try to like predict the future, but because you're predicting the future, you might end up predicting it wrong. So then, like, what you need to have happen is if you predicted it wrong, you need to resolve that somehow. I like how you drew error not equal to nil, return error on that diagram. Yeah, and I even included the Rust version too, the question mark. Don't worry, I always talk about Rust at least once on stream. So you can predict where you think you are, but if you're wrong, you need to you obviously need to resolve that somehow, because you want the player to be as close as possible. You want the player, like, the objective is to keep the player as close as possible to where they are on the server, and at the same time, like, make it visually smooth. So you make it visually smooth this way, at the cost of making them further away, and then you try to make them closer by doing it this way. And then you can do client prediction, where you basically store their inputs. you can store their inputs in a buffer. And then you can replay those. And these are the ones that haven't been sent back from the server yet. Just switched already to Rust. Not a chance. I don't think I'll ever switch to, I don't know, maybe I will one day. It'll be a little bit of time. Client prediction is the reason lag back is a thing, right? Oh, are you talking about the thing, are you talking about where like he moves, oh, yeah, if you minimize the screen for a while, because it's in a browser, it gets all messed up. You're talking about where like it moves and he slides back? Like he goes like this? Is that what you mean by lag back? Yeah, that's exactly right. So he runs up and like the client's predicting that you're up here, so you're moving up to there, and then the server's like, actually, like you didn't make it that far, you went actually back here, so you go back there. So I'm trying to resolve both of those. Right now how the client predict, or right now how the interpolation, I have client prediction, which is working, and that works fine, it seems. The problem is I'm not storing an interpolation buffer, depending on your lag. I'm just storing the latest one. And you're constantly interpolating to this one. So you can kind of see this blue marker is where you're predicted at. Well, you can see it jittering around. That's where like they got a new packet came in and it replays it. What's up, X Hyped? How you doing today? Yeah, so there's some pretty bad jitter still. So hopefully by extending the replay buffer just a little bit, we can smooth all of that out. Oh, thank you. They're wrestling. Does the client also predict where other clients will move? No. It's the reason you can do client prediction on yourself and not other people as effectively is because when you client predict on yourself, there's like maybe 5 frames or so where you're actually giving input to the game, but that hasn't made it to the server and back yet. So like you can predict those 5 frames on your screen in hopes that the server is going to receive those and process those on the right tick, you know? So you can predict that pretty well. But when you're on when it's somebody else, you don't have those next 5 frames of input. All you have is where they were last frame and where they are next frame. You do have their input as well, but you have their input on that frame. So what you could do is you could say like, I hope they just keep going in the same direction, and you can extrapolate that way. Like you could say like, oh, this guy was like previously moving in this direction, so I can just extrapolate him that way. Like I can just say like, oh, he's gonna keep moving that direction. And that might be somewhat effective. It's gonna be wrong a lot though, because if they ever turn, now you're gonna be wrong. So you can use interpolation to smooth that a little bit, I guess, but yeah. Those cats are cute. They wake me up super early though. They wake me up at like 5, and it's just them like eating my hair or licking my head or something. Yeah, that's a problem in a lot of games. And actually, like a lot of this stuff can be solved by just regionalizing your game. Because like you can kind of see on mine, like it's pretty smooth, and I don't really have that much going on. This is like the very old method, and my ping spikes are fairly high. Like it goes like 150 sometimes. You get like a little hiccup. So I'm hoping to smooth that stuff out, and I'm hoping to dynamically make it better for even higher pings. Yeah. Well, it's definitely worth it. I have to stand up. I have a sit stand desk, so I have to stand at my desk when I want to work, because otherwise, if I sit here, they're just gonna hop up on my desk and get me to play with them or pet them or something, or they get on my desk and they fight, which is just the worst. But I do love it. I feel like when I drew this out, I had like a plan of kind of what I was gonna draw. They already have a good influence on you. Yeah, they do. I bought them like a little, not sitting, I know exactly. I'm healthy now. I got them a, you know those like towers, those cat towers? You know what I'm talking about? I got one of those. Yeah. So that's coming in the mail. Hopefully hopefully that'll entertain them a little bit more. The problem is I think they want to be next to me. So when I'm sitting, they want to be like right here in front of me, you know? But they can't always be right in front of me. So that's where the coffee money went. Exactly. Hey, what's up, Sammy? How you doing? All my money goes towards my cats. Actually more expensive than I thought I was gonna be. But they're good kitties. They just like to have fun. My cats also want to be next to me all the time. Yeah. Like I go in the other room and they just like they gallop in bed with a headache. Oh, I'm sorry. That's no fun. Hope you feel better. Oh, it's not anything too serious. Okay. So let's say this is the timeline on the server, and the timeline on the server is like the source of truth, I guess, for every simulating client. Golang will surely soothe my brain. I hope so. Let me go in my deep radio voice mode. If only I had one. But anyways, the as the ticks come over the network to the client, they might get dropped. So let's say that like let's say there's some where our buffer's already like kind of full maybe. And let's say that like this one gets dropped. We get this one. Or maybe we can draw out the state of everything actually. Let's do that. So we'll say this is the very first one. We'll just keep going down. Right there. Okay. Let me do another one just so we have room. I don't know how many I'm gonna need. Okay. So the client's gonna get one. Let's say the client gets this tick. Let's say he gets the first three. 1, 2, 3. Then maybe he drops this one. So then the buffer's gonna have 1 in it. Then the buffer's gonna have 2 in it. This is a queue actually. It's not really a buffer, I guess, but same thing. Then it's gonna have 3 in it. And then he's also gonna have 3 in it. Let's say he gets this one. And then he drops this one. Now he would have 4. This would have 4 as well. That's 3. Oh, that's 4. Let's say he gets the last 2. We have 5. 1, 2, 3, 4, 5. Then we have 6. 1, 2, 3, 4, 5, 6. Okay. So then when I replay, I guess this one could be. You said you probably will never change to Rust. Is there anything in your opinion that Go does way better than Rust? What do you like about Go? I just feel like most of the problems that you had in like more low-level languages like C and C++ were are really solved by well, like there's 2 ways to solve them, I guess. You can either have a garbage collector that enforces them all for you, which is what Go did, or you could have the do like the static analysis stuff that Rust does. And I feel like for the types of applications that I write, doing the having the garbage collector just do it for me makes me more productive and it is like good enough. There is the occasional time though where I'm like, oh, if I was using like Rust here, I can make this a lot faster. But it's mostly just like developer ergonomics for me. But and like also especially like you can really minimize your garbage collector impact by just making by like building things in such a way that they're like everything's put into arrays, you know? Like if you structure everything with just a bunch of arrays, then you're not going to have as much garbage collector impact. So you can kind of like minimize some of your performance problems that way. And I think Go binaries are like pretty much just as fast as Rust binaries in terms of like compiler optimizations. Like it seems just as good to me. There might be a few things though where like there might be assembly intrinsics I think you can't use in Go that you might be able to use in Rust, but yeah, I think if I switched to Rust, it would be performance reasons. I just think Go's a better prototyping language. I would use Rust if there's a way to like turn everything off and let me just like code stuff, and then I could like harden it later, you know? Because how I develop is I do like very experimental stuff. As you can tell, it's like pretty right. Like I kind of just like crap stuff out, and then at the end of it, I'm like, oh, now I kind of understand my problem. I can turn it into a library and then use it forever. So like that part at the last library part, there is a way to turn it off unsafe. Yeah. Um, at the point at which where I turn it into a library, I I would be fine with using Rust, but everything up to that point I don't really like. Nice prototyping language where unused variable is error. Yeah, I guess that's one downside of prototyping in Go. And also a lot of times I'll comment some chunk of code out and I'll have to like go up here to the packages and comment out the package I stopped using. Jomi dropped the gun down. Don't do it, Jomi. Don't you run that unsafe code. He's got it out of his system now. What if everything was unsafe? Then we have a safe keyword. Ooh. Now that's interesting. I would honestly like, the thing is like I don't want my code to ever be unsafe, but it would be nice if there was a way to like write Rust, but in like a garbage collector way, you know, without the mutability guarantees. So I could do that most of the time, and then when I want to like harden something, I could turn it into the static version. Also, Rust build times are just really slow. That's called Swift unit. Is it really? But Apple makes Swift, right? I can't use that. Hold on, I gotta take a little break. I need to interact with my cats. They're biting my cables, which means they need a little attention. Give me 1 second. They just hit my power button. Uh-oh, that was really close. Whew, good thing that didn't turn off. That would have been bad. All right, I'll be right back. All right. They seem a little, I played with them a little bit. They got a little bit of their energy out. Are you using Cgoat in your projects? Yes, so for the OpenGL bindings and GLFW bindings, I use Cgo. But then for the server, I don't use it, and the proxy server, I don't use it. And then WebGL, I don't have to use it either because I use WebGL, which has JavaScript bindings. So I call it JavaScript. What did you say? I don't remember what I said. I'm about to get squirt gunned. Just get a thread ripper, compile times become fast. Unit still stuck within the JVM. Yep. I'm always in the JVM. Really, Java's the optimal language. I just can't afford my Oracle licenses. So yeah, I have to use Go instead. If only I was a rich man, then I could use Java again. The perfect concoction of a language. Okay. Then what gets replayed? So we only have one. So we're always going to interpolate to a position. So we're going to interpolate to 1. Then here, we're still going to be in, we should, it's weird, like when we don't have many in our queue, we want to slow down the interpolation because we want our queue to expand. Just use Kotlin. Maybe I should. That's just the answer right there. This is where it becomes hard. It becomes like a weird balancing though. It's like, I want to slow down now. I want to slow down to make my buffer bigger, right? So whatever that means, either that means waiting to move, or it means moving slower. Then we have like the right number. We want to run at the right speed. Normal speed. But then here, still don't have any new fancy new emojis. Yeah, I was looking at adding them. I think I can add new emojis, but I have to I can add new emojis, but I have to make like, they have to be like tied to a YouTube membership. That was the only way it looked like, unfortunately. I wanted to add emojis though. I feel like that'd be cool, but maybe I will add them, but people have to pay for them, unfortunately. So I don't know if that's really worth it. Maybe one day. But I did look at it. I looked into it a little bit. Let's see here. Oh, you're talking about those ones. Oh, you need to update your app. YouTube doesn't like you. You probably just need to do a little update there, buddy. And then you'll be right as rain. Let's see here. Like, let's say we still interpolating to 1 because we're going slow. Then maybe we interpolate to 2, which means we also have to go slow. I just don't know if it's better to start late. Oh, you're on the latest version. I don't know then. What do you have, an Android or a It's because you're on your phone, I bet. They just haven't rolled it out for phones, probably. Maybe you're on your computer. I don't know, actually. I feel like you're usually on the phone. iOS. Yeah, there you go. Another Apple product with a failing ecosystem. I'm just kidding. Apple's not bad. They have good hardware. I will say that. Yeah. Phone streaming to TV. Oh, that's interesting. That's like a Chromecast almost. So we're interpolating to the second one, which is this one. The weird thing though is that Apple is kind of okay, but it would be so much better if they allowed people to modify their products. Yeah, I agree. They call it AirPlay. Gotcha. Yeah. Yeah, I don't think Apple's a bad company. Like in terms of what they produce, I'm not a big fan of their OS, just because I think Linux. I've just customized Linux how I like it. I don't really want to use homebrew to install packages, and I don't like their package manager that comes with like the App Store, I guess it is, to install apps. So I don't know how hard it is to install Linux on a Mac, but maybe one day. Maybe one day I'll buy a Mac. I have had one before for work, but what's wrong with homebrew? I just feel like it wasn't as good as Linux package managers. I felt like I was always running into some weird situation where like a package didn't exist or that I wanted to use. Oh, it's definitely nice. I just don't think it's as good as like Pac-Man on Arch or anything like that. Like I almost never run into a situation where I can't find a Pac-Man package, like a Linux package that I want to use on Linux. But when I was using Homebrew to install stuff, I had more trouble, I guess. I don't remember exactly. Arch, by the way. Yeah. Oh yeah. And by the way, guys, I use Arch. Yeah. Homebrew is okay most of the time, but definitely not as good as Pac-Man. Yeah. It could also be that like I had a work laptop, and they like locked stuff down more. So also don't have any new emojis on the PC either. Oh, interesting. You must be in the control group of the YouTube emoji experiment. I should cover my power button so my cats don't step on it. I was playing Apex Legends with with one of my family members. Like I think it was it was 2 days ago. 2 days ago I was playing and, and my cat stepped on my. We were like in the top 5 or something like that. So like we might not have won, but we were like getting really close to the end. And then my cat steps on my power button on my computer and it just power cycles it. It just turns off completely. All I see is the screen go to like shutting down. And I look down, and the cat's just looking at me like I don't know what I did. I wish I was in the control group of the new UI. Yeah, that'd be the experimental group. That's the one I'm in. But anyways, needless to say, I died. I tried to restart as fast as I could, but it didn't work. I don't know. I guess we're still going to 2 here. We have 3 ticks. But it probably gets I guess this would be used. These are pulled out of the queue. Look at the children. Oh, the cats. They are definitely cute. I think they know. They know that I don't like them to be near my power supply and all my cables. So that's where they go because that's where I go and interact with them. They like go and wait there so that I'll go pet them or something. I don't know. It is pretty cute though, but. Give me 1 second. Back here. All right, cat saved. Cat saved from the power box. Don't chew on that. What were we doing here? Oh yeah. So our goal, I guess our goal when we don't have enough ticks is to run in a slower mode so that we get more ticks. But I think the way I'm doing it right now, where I sorry, my cat being obnoxious. I think the way I'm doing it right now, where I'm doing this hard cutoff, I need to do it more linearly so you don't detect that I'm going slower, that you're going that much slower. That's what I think. Hmm. All right, give me one second. I gotta go play with my kitties really quick. I'll be right back. All right. I just gotta get them a little distracted. Why not study what people did before you? I have. There's this one guy, Gaffer on Games, who has good articles about this. So I'm trying to implement kind of what he did. The problem is they don't explain like every single thing that they do, so you have to kind of read between the lines a little bit. So that is where we are right now. I have the buffering part working properly. I'm not sure exactly how to like stabilize how big the buffer is. WRIS. What's up, Layson? How you doing? All right. Maybe if I come up with some like linear function where it runs slower. Where you move slower. It's just hard because this is the hard situation right here. Is where when you drop a packet, that means that there's like, this might be a further distance than the normal interpolation. So if I keep like a constant interpolation time, which is like the tick rate that I send stuff at, and I'd never drop packets, it would be fine. But because I can drop packets like this one, then because I can drop packets, I now have this like long distance that you potentially need to cover. So if I keep the interpolation length flat, like the same across everything, like constant, then what might end up happening is that this segment you're gonna move a lot faster, and that's why you get that like jittery movement. So here I need to like almost double it, or I need to have it moving at the right speed. Oh, thank you, Jomi. I appreciate it, buddy. Doing good on the stream. Thanks, man. You get the cat WrestleMania too. That's gotta be worth something, I think, right? Thanks, buddy. I appreciate it. I hope you're having a good day. What are you working on today? More ECS implementations, I hope. No, sadly not. Aw. Doing the advent code problem. Oh, I didn't even know that was going on yet. I thought that was a December thing. In C. Nice. I've never done that before. That would be an interesting thing to do, though. Wouldn't that be in December? Oh, it starts just December 1. Gotcha. But it's only the 29th. I'm doing the one from last year. Gotcha. That's cool. Yeah, I thought about doing those. Those seem like they'd be pretty fun to do. Can't use the client's internet connection speed to dictate the tick for each client individually instead of the server tick. To dictate the tick for each client individually instead of the server's tick. Yeah, so I was thinking of keeping like a running average of like how frequently ticks come in, but I think I'd still have to go a little bit slow. Like I think it's still like the average would end up being the server average. As long as nothing gets dropped, it would end up being the server average. No, they should be running at the same tick rate. So that shouldn't be a problem. I did think about that, and that would fix this. I just don't know if that's going to be, I don't know if that's going to keep it stable. Because I would basically keep an average of all of their ticks, but like, I guess I'd have to do a trailing average, maybe do like the last 10. There's ends up being a lot of like small tweak things. I'm looking to find like what the right, I'm trying to find like I think this is a like, you want to slow down when it's too small, you want to speed up when it's too big, you know? And the rate at which you do that is the thing I'm trying to figure out, like what it should be. I think if I just keep the average, I had thought about doing this. I think if I just keep the average, I think it's not going to be, I think it's not going to like stabilize it. Like, I don't think it's going to stabilize it the way that I would hope, I guess. For this year's advent of code, I'll randomly pick a language every day. Oh, that's kind of cool. Dang, so that's going to be like 25 different language. Can't wait to see the brainfuck solution. Got a list of all the languages I know and one I want to learn. A list with 11 items. Oh, dang. Oh, is it just 11? Is it 11? Is it 11 problems? Damn, that's a lot. If you're gonna hate yourself, I think you do it wrong. Wait, if you are going to hate yourself, I think you do it wrong. Is that to Jomi or me? I don't know. I'm confused. I forgot to add brain fuck. Not gonna happen. Yeah, that sounds super painful. Have you got Haskell on your list? That's a good question. No, it's a full month, but I don't know that many languages. Gotcha. Yeah, I'd probably do probably bad, but I'll hate myself. Yes. I do not know Haskell. Time to learn. Get on that functional programming grind. Honestly, when I was learning Haskell, the biggest complaint I have about Haskell is that installing the packages for it took up so much space. I don't know what it was, but those packages were big. I know Haskell, great guy. Very friendly. Pretty tall too. Should be in the he should play basketball. I'm trying to learn right now, same with Common Lisp. Oh nice. I know like barely, I barely know Lisp just because I use Emacs, so you have to configure it with Lisp. I wrote a Lisp in Go, it's called Let Go. That's kind of cool. Wait, why'd you call it Let Go? Oh, just because like let go of things? Let go of sanity. Could you do a moving average with a predictive approach? Like a Arima model. It's a pun. I like it. I like the pun. I had thought about doing a trailing or a moving average. I guess I was calling it trailing average of like the last 10 ticks or something like that. You would have like, oh, it's like 17 milliseconds per thing you receive. I just don't know if that's going to stabilize it to the point that I want it to be stabilized at. I mean, I guess we could try it and just see how it turns out, but this is like almost like a controls problem, I think. Autoregressive integrated moving average. I've never even heard of this. Hmm. Interesting. I like all the ML stuff that's come out recently. What I was thinking of doing was I was thinking of just slowing down the move speed. Like I have this where is it? Okay, I have to go work on my patron killer project. Nice, dude. Good luck. Hope it goes well. That sounds interesting. I can't wait to see the release. Let's see here. I had done this a little bit. What did I do? This is what I was trying yesterday, but it was earlier on. I was before what earlier what I was doing was I was trying to find like the distance that I wanted the player to be at away from, and I was calculating the speed. I was calculating like a a line basically. Here I can pull it up. I was calculating a plot from like the normal speed to like some slowdown speed, and the goal would be that the slowdown speed would extend the number of ticks you have, and the speed up speed would uh, decrease the number of ticks you have, and then you would just use that speed to do all of your movement. There's an error package that does exactly the wrapping you're talking about. Oh yeah, yeah. I think you must be watching earlier on in the stream. I think who was saying it? PSIT was saying it. Yeah, package.errors or package/errors. It's not the standard lib, but it's very similar interface with some added methods. Yeah. I looked on GitHub for it, but it looks like it's archived. So I'm curious why it got archived. Hmm. How am I doing the movement? I'm doing interpolation right now. When I calculate the total time, let's see here. Let's do one. I'm just curious what 1 plus looks like here. I might just do a little bit of experimenting and just see how. So now it's going too slow, I think, to where I'm just snapping to the endpoint. Like I'm snapping to the most. Well, actually, that doesn't make sense, does it? Hmm. That was an interesting spike. However, the slow progress. This is kind of a tricky one for me. But I think once I solve this, I think networking will be very smooth. The problem with using time to interpolate is that if there is any big jumps, you almost have to like recalculate based off of your speed how long you want it to take to move there. So I feel like moving based off of the interpolation time is the wrong way to move. I'm gonna change this. I'm gonna go back to the physics moving. So instead I'm gonna use my speed and move at that rate. And I think I'm gonna tweak the speed based off of how far we are from the tick. I think that makes sense. What's my oh, I want to look at total. I think I'm gonna go back to I really need to clean this stuff up. I've gotten really sloppy with this problem. Let's see here. I'm just gonna use the pre-computed average tick time. So now the ticks are, well, yeah, the problem is I get this situation where it's like reading them too fast. I feel like I have some timing bug somewhere, and I don't really know exactly where. Let me do this really quick. I'll just turn off lag. It's so strange. Is reading it like 4? What is this? It's like 4. That's like 4. That's like 4. I think I have some bug here. Let me do some printouts really quick. I'm just curious what this is becoming. Log.print next t.remaining remaining. Oh. Hmm. Interesting. It's interesting that it goes to negative 48. Oh, that's because. Oh, that's why there's that's why there's 4, I guess. That doesn't make sense actually. Will you pull the one off? Can we reset the timer? We reset the timer here. And then we have a bunch of reads where there's nothing there, basically. Hmm. 48, 32, 16, 0. And then there's none to remove, none to remove, none to remove. We just keep decrementing until one finally pops into the queue. And that would be the next tick that came in. So we're always waiting on a tick. Which means that the wait time needs to I think the wait time does have to dynamically change. I think it has to dynamically change up and down though. I think maybe I'll go back to this method. We'll just see what that looks like. So now we're the right distance behind, you know? Like we're 3 ticks behind. Look at that. Now all that needs to change, I think, is if I remember correctly, this first thing, this is the length. Yeah. This is keeping the let's add lag now. Yeah, this is eating up. Like you can see, like when there's a big spike, we do snap to the next one. Like yeah, see how it goes to 1? And if it gets to 0, like that's just a problem, right? That's a flag's just too bad. We needed to make the buffer bigger. Sorry, I mistyped. But the Surima suggestion in hopes that you can predict the size you need, but it would require a large array of data. Gotta head out back to the replay. Keep going. Oh, thanks, buddy. Yeah, no, that's an interesting suggestion. I wasn't aware of those types of moving averages, but those sound kind of neat. I think the problem with those though, the problem with like that I had with doing a moving average is it didn't let me like tune. Like I don't want it to wait. It's kind of hard to explain. I don't want it to wait the perfect amount of time. I want it to be I want it to wait the amount of time that like lures my character to the right number of ticks behind where he should be. And I think how I have right now like looks pretty good. Like you can kind of see how it's going like from 3. 3 is normal when there's no jitter. They don't have a big spike. They'll drop to like 2 or 1 or sometimes maybe even 0. And all of those are situations where the tick is decreasing. I think all I have to do now is I just need to move my character at the right speed so that I'm smoothly going through those rather than like jittery going through them. Because right now I'm like moving to it and I'm stopping, I think. But I want to always be smoothly interpolating to the next thing. Well, those look pretty bad. That might be because my Emacs buffer is getting big though. Emacs doesn't handle a lot of printouts very well. It is weird that the speed's increasing though when it gets far away. That might have been because of the printouts though. Like a bunch of frames are just getting replayed all at once. I need to decrease the amount of printouts I have, I think. Let's do this. What it looks like is happening though is it looks like I'm getting there and I'm stopping. Like I'm getting to where I should have been interpolating to. I need to move slower. It's weird because I want to like arrive there. Hmm. I want to arrive there right when it pops off. Right when it comes off of the queue. I'm curious if that Gaffron Games article talks about this at all. Like how he smooths it. Let's see here. Networked physics. Physics in 3D. All right, let's just go to articles. I think snapshot interpolation is what I wanted. Okay. Handling real world collisions. Okay, one technique that people often use is to hide the delay added by the interpolation buffer in other areas. Oh, that's where's Okay. Now for the trick with snapshots, what we do is instead of immediately rendering snapshot data received, is that we buffer snapshots for a short amount of time in an interpolation buffer. This interpolation buffer holds on to snapshots for a period of time such that you not only have the snapshot you want to render, but also statistically speaking, you are very likely to have the next snapshot as well. Then as the right side moves forward in time, we interpolate between the position and orientation of the two slightly delayed snapshots, providing the illusion of smooth movement. In effect, we traded a small amount of latency for smoothness. Look closely. So, and you can see some artifacts on the right side. The first is subtle position jitter when the player, the cube is moving through the air. The other artifact approves on a bunch of cubes on the camera. You can sort of see pulsing. Oh. And this is just a different interpolation method. The hard part is knowing where, maybe I should do a moving average. The problem I'm having though, when I did the problem is each tick has a different distance, depending on if the previous packet was dropped or not. And that's the part, I don't know if I should be using time to interpolate these, or I should be using the speed. I feel like I should be using the speed, and that'll normalize this stuff better, where I drop a packet right here. Then he's just moving at a constant speed, and that's gonna be the same thing, you know? It's almost like I need to know how long that's gonna be. If I take the speed, let me think about this. Okay, if I take the speed and use that to calculate how long it's going to take to move there, then that can be the next delay. And that should be the equivalent of doing an interpolation between these 2 points. But I take the speed, I use the speed to calculate how long the interpolation should be. The weird thing is, like, in his explanation where he's like, oh, you just hold them in a buffer for a certain amount of time. Like, I don't think that works if you just replay it normally. You have to smooth that all out. And that's the part that's kind of confusing, is how do you smooth that out? And I think that this speed needs to change depending on how big this buffer is. I'll be right back. I'm gonna go to the bathroom really quick and then think about this a little bit more. Give me 1 second. All right. I wish I could say I came back with a revitalized perspective, but I cannot say that, unfortunately. So we'll have to keep thinking about this guy. I think the speed at which I move, helps determine how big this replay, this buffer is going to be. And I want that to be smoothly determined. And then I can use that same speed to determine how long it's going to take to move. Man, drop packets are just a nightmare. I really don't have the answer here. I feel like I'm missing something. I feel like I'm missing a simpler solution. It's like it's all about balancing like how quickly these are produced and how quickly these are consumed. And I'm not really sure how to balance that. I wonder how like I don't know. I wonder how people do it for like okay. Decoupling the detection of work from the execution of work means you control how many threads at a time. I'm not sure how to balance this. I feel like this is a very similar type of problem. Back pressure management. If the producer threads produce more work than the consumer threads are able to handle, the tasks will queue up in the queue, and at some point the blocking queue will become full. I want to avoid that. Okay, that didn't really answer anything except explain that. The one language to rule them all, Java. Forged in fire. Oh boy. I like the drama. I feel like my congestion control is the speed at which my guy moves. Because I don't really know how else you could do it. Burdened by its legacy. Dang, you should be a writer. You need to write these lines down. Doomed by backwards compatibility. I feel like there's a lot of things doomed by backwards compatibility. Everything in software. Okay. I've spoken to the inventor of it recently. Java? Wait, the inventor of what? Oh, what's his name? I watched a Alex Friedman podcast with him on it. Brian Carnegie. Brian. Yeah, I think Kerningen. Kerning. I don't know. What'd you guys talk about? That's pretty. That's pretty cool. How'd you get to do that? Hmm. Let me plot this. Okay. Y equals mx plus b. James Gosling. Oh, yeah, yeah. Okay, you're right. He was on this though. Yeah, yeah, yeah. I watched this. Who am I thinking of? Uh, Brian Kernigan. Oh, he did Unix. Okay. Gotcha. This is the guy that wrote the C book. That's right. We were at the same conference and just had a chat about the Belgian weather. Interesting. What kind of conference? What conference was it? Or I guess you don't have I don't want to pry too much, but I guess it was in Belgium. We'll do 200. Well, this is going to be 200. Because I think this is going to be the minimum speed you would go down to slow down. There's a yearly Java conference called Devox. Oh, interesting. Are you really into Java, Sammy? Yeah, the Belgium weather conference, of course. Of course. What was I thinking? Um, and my company was there and I was included. Oh, interesting. That's super sweet. I did 3. I'm officially a Java dev. Uh-oh. Uh-oh. This is technically B. That's like the slowdown point. And I need to zoom out. So this is going to be a line basically from 100 to 200. 200 should be the speed. 100 we'll say is the minimum speed. But we could drop that down, I guess. That's kind of configurable, I think. Optimal distance. This is the wrong thing, though. I want to do a different if statement here. This is gonna be the target delay, which right now I have it set to 3. Well, we'll do it the other way. If the number of elements in our buffer is less than the target delay, then we want to slow down by the Java and C#, the enterprise dream. Oh, you use both of them? That's kind of crazy. I guess if I hate Java, but Kotlin, I like Kotlin. That's like where C# is. Modern C# has almost the same features that Kotlin has. Oh, nice. I've never used Kotlin before. I've done a little bit of C# just in Unity and XNA. And I have done Java. Oh, good morning, JJ. How you doing? I don't know that much about Kotlin, other than I think it's functional. And it's on Java. It's on the JVM. Depends on what project I'm consulting at. Interesting. That sounds like a pretty sweet gig. You okay? What I miss? Uh-oh. You've missed a lot of pain. That's what you've missed. The cats are asleep now, so we got a little breathing room to work. They're rambunctious though. Okay, so if there's one thing in here divided by 1, I think I want this to be divided by the target delay, which would be 3. And then I want, yeah, this is right. This is the number of elements in our buffer. So if the number of elements in our buffer is less than what we want, then we're going to slow down based off of this curve from 100 to 200, where 200 should be, that should be the speed at which things move. But we shall see. And then, yeah. And then, yeah. We're going to do this. Target delay. Current delay. Wait, this is target delay. Okay, I wonder what the speed is at. The speed should be around 200 right now because we're 3 away. Where's my log? Am I printing? Let's print 39. Okay. ID, speed divided by dt, which is mostly 200. I guess if we get too close, we slow down though, which is good. It is weird though that we still need to use speed to determine how long. They should have a bank. Projects are so important, but people don't seem to want the same things. Yeah. Technical solution is not that exciting. Making something that people will actually use, and the politics behind it is really interesting. Oh, interesting. I don't think I've ever heard someone say that they enjoy the politics. So you're the first. We could probably make this slow. So now we have it's gonna go by thirds, right? That's why it goes to 66. 166. Let's make this even less. Like maybe 0. The problem is it's going to be really big. I think I need to use the speed to calculate the distance that, or we need to use the speed and the distance to calculate how long we need to wait for the next one. Let me see here. This is such a tough balancing. I don't know. I just feel like everything, I just feel like everything that I'm going to try isn't going to pan out the way I want. Maybe I should be calculating an average here. Let me go back to my drawing. It's weird because I constantly want to be, let's do this actually. Let's make our target, let's do like 6. So you can see where there's drops, and that'll cause some, but everything's mostly equidistant. There's a 1 packet drop, for example. And that's where the speed ups happen. So when you have the packet drop, you can see he moves faster. Because he's trying to close that distance in the right amount of time, it seems like. Other than that, though, it's constantly like getting there and stopping, getting there and stopping. And that's where the jitter comes from. Let me read JJ's. I want to do game programmer, start on the graphics trap. Oh, interesting, interesting. Switched though, went away. Unit and those of you doing game dev, I'm like filling a void missing in my life. One day I'll try again once my career is going. Nice. Yeah, I think you can, if you have a software engineering degree, I'm sure you can find a job out there. You just gotta look, and then game dev on the side until you have enough money to, money or experience to get a job in game dev. I feel like now that I have these points, I should be able to interpolate perfectly. I don't know why this is so hard. It's so strange to me that like my top speed should be 200, but I don't understand why I'm going so much faster. Because 200 is the speed that he's running on the server. Even 150 is going too fast. I feel like this is a bug. See, it's like he's walking at 125. There's also the problem when I'm doing this vector movement thing, sometimes you walk past a dot and you want to go to the next one. So I need to have some sort of like, if you're going to pass it, you need to apply it to the next one. Not all game studios require degrees, some just enough passion, or just making your own indie games is enough. That's pretty cool. Yeah, I've never worked in a game studio before. That sounds reasonable to me. Also, there's a ton more in game dev than client development. Wait, what do you mean? Like, oh, like graphics you mean by client? Or like people clients? My problem is no art talent. You can just get the art packs online. Or draw some shitty pixel art like me. Actually, I think this guy looks pretty cool. I'm not gonna lie. I like him. Oh, more than just graphic stuff. Yeah, I gotcha. Oh yeah, there's a ton to it. Mm. Mm. Let's go back and look what the interp looks like. Um, oh, interp package missing. See, I don't know why this is oh, am I snapping still? Yeah, if I get too far, I snap. I want to disable that. Actually, I want to make this like ×8 or something. Just so I snap at the start. It's weird to me that this is snapping at all. My best friend keeps pushing me to make help him work on his games. That could be fun. There's learning to do there, but really, do people get their career choice right the first time? I 100% agree with that. I don't think it necessarily matters what your first like programmer job is. So I think just apply and get something, even if it's like IT or something like that, and just move up the ranks. To some degree, you have to like, you have to find that path to getting to where you want. You don't necessarily need to go straight for what you want. I think a good starting point for that path is just to get like a software job. So I think just break down the problem and yeah. I'd really like to look into. Oh, I really advise to look into some things you love the most. Game dev and game engine dev are two really different things. Yeah, I agree with that. Unless you're me, and then you, yeah, I feel like I'm more interested in engine dev than I am interested in like gameplay development. I don't know where to apply with no portfolio. The job site in a studio you like, yeah, that's good. That's a good option. And at some point, you just have to get a bunch of like it's a numbers game. Like let's say you get 10%, you pass the interview. Like 10% of places you pass the interview on, and 50% of places just don't let you interview. So like crunch those numbers. I was hoping I was gonna be able to do that in my head, but I don't know. How many would you need to do then? So if you did 100, you get 50 interviews, and 10 of those would pan out. So apply to 100 places. You get 10. You'll get 10 jobs. Hmm. I think this is the wrong interpolation to use. I feel like this should work exactly right though. I'm interpolating from where I am to the next point, and I'm doing it in this amount of time. I don't know why it's hitching at all. Because you think once I get to 1, once I get to 1, I should just so I'm going past it. That's not good. That only happened once though. I was interpolating from 0 to 1, and this seems pretty good. And a few times I go past it. I just don't know why it's stopping. I wonder if these are wrong. Interp start, what is that being set to? This should be set to your current position. Wait, you're at a position, and every time I pop one off of my queue, I take that position. That's where you're going to interpolate from, and you're going to interpolate to the value that gets popped off. Let me just make sure this isn't being set somewhere else. Maybe interp 2 is being set somewhere. Wait, actually, we print those, don't we? We can just look. No, it's the same. That's the same. That's the same. That would imply that we're not pulling I don't know. Is my time changing? No, it seems like it's interpolating exactly right. What's up, Sebastian? How you doing today? Unit does great work with OpenGL. Thank you. I don't know. I wouldn't consider myself an OpenGL expert by any means, but I do know a little bit. I know enough to make a 2D game. Um, I just don't know why this is skipping. It's like what I imagine should be happening. I wonder what when it transitions, I wonder what happens. Wait, why are all these let's look at a different one. We'll look at this one. That one skips too. This one doesn't. Okay, we'll look at this one. So 173 should be, yeah, should be this one. Oh, this is interesting. 160. Then it goes to 162. 173, 173. So this one lined up perfectly. 186, 186. So the hitching must happen when I go over. Let's see. 1037. Oh, wait. 1050, 1051. Yeah, because we went over. I don't know why that would cause a hiccup though. Let's do this. Well, instead of keeping going past it, if interp factor is less than 1, then we'll interpolate. If it's greater than 1, we're going to not interpolate. It's a little bit smoother. So that was one problem. Now he's just stopping though. He's not going past, which is good. I did have one thought though. What was it? All my cats are sleeping together now. They're all cuddled up. It's adorable. That's kind of a big jump. But this doesn't get to, oh. I need to greater than or equal to. I wonder if it's switching before it gets to 1. No, I don't think so. Let me just go straight down. I just want to see if it transitions properly. Okay. I guess there are 2 frames. Oh. There are 2 frames where I'm at the same position. That explains a lot of the skipping, or a lot of the pausing and moving. Because every time there's 2 frames where I'm at the same exact position. No, wait. Is that right? No, that's not right. Let me draw. Let me also print out the what is it? IT. Okay. Let's look at this guy. Well, let's look at this loop here. These two interrelations. We go from 527 to 502. And this should go up to, he's going past it though. He's going to 504. Wait a second. Oh, 527, he's going down. So he's not quite making it to 502. Then this place, oh, because I'm printing before you move. Let's print after you move. Watching you code while listening to Interstellar Overdrive is something different. That sounds pretty cool. Is that a playlist on YouTube? I might have to go listen to that. I get resumes from new grads and fast food workers when I have a senior 2 position open. It's all about getting an interview and understanding what to focus on. What the focus is. A lot of job postings are for unicorns. Yeah, I agree. I think it's about applying and just getting interviews, and then it's a numbers game after that. It's a numbers game once you apply. Watching Unit look at console, pinnacle of entertainment. Hey, you guys signed up for this. You gotta put your 8 hours in, okay? Just like the rest of us. There are a lot of jobs in the game industry, a lot remote. Don't focus on one that isn't feasible. Yeah, I agree with that. It's about getting a job. Like, once you have a job, it's a lot easier to get a different job and to like move around. It's a lot easier. Just because, like, just mentally, it's like you don't have to leave, but so you can still explore if you want. When you don't have a job, it's like a little bit more like why, like the questions might be like, why doesn't he have a job? You know, it's hard to get your foot in the door. Once your foot's in the door, you can move laterally and you can move up a lot easier. It's harder to, because you have a little bit of trust with the people you work with and they know you're doing a good job. They know stuff, they know you, they know you're reliable or whatever. And then they just trust you more. So you can get away with a lot more. Not to say you should like do bad stuff, but you have a little bit more like social capital once you have a job. And it genuinely does not matter what your job is. Like the problem with not having a job is you don't have the opportunity to show what you can do. So once you have a job, now you have an opportunity to show what you're capable of. And so once you can show what you're capable of, people will look for you for other things. And it's also like more resume fodder. Let's see here. When this transitions, okay, well, you're at the perfect spot now. Oh, so we do stay at the same spot for a tick. Look at that. 800, 502, 800, 502. So that's not good. What does that mean? Is that all situations? Yeah, it looks like it. I feel like this is going back to I have this like fixed time step, but the interp start shouldn't be your position. It should be your position, but moved, like interpolated once. I don't know how to calculate that. I could do this actually. I'm gonna do, because I have this interpolation. I have this interpolation from 0 to 1. And then that's gonna get divided up here. So I want to add on this amount. And this amount should be every tick. So I think I want to do like single dt.seconds divided by next t.total.seconds. And we'll add on this flat single tick, because this is a fixed time, which is 16 milliseconds, because that's my tick rate. And then this will be the total for the whole thing. And I'm just going to add on that. And then that means you're going to start here now in the interpolation. Wait, but then you're going to go. Yeah, the problem is that's going to shift you out, which I don't want. What I want to do is I want to squeeze. I really want the time to be the same. I could subtract out a dt then. I could add in the dt. And then make this smaller. No, this needs to be the same. Or when I set remaining, I can just set it to subtract out dt. Let me try that. Remaining. Let me see if this works. What that'll do is that'll change this to be, wait. Oh, total. That effectively puts us there. Because when remaining is max, it's here, and then I subtract 1 dt. Try this. Nope, still hitching a lot. Is he now there's no 0, so it's just going straight to 1.5. But this is changing, so that's good. We do 1. What a tricky one. I know the problem with why it's going fast. I just don't know why it's stopping still. Or maybe it isn't really stopping. It just looks like it's stopping because it's going fast and slow. It's going fast because of this. We interpolate the same time here still, even though we dropped this packet. I could try to use. Man, once I finish this, once I fix this problem, I'm gonna be so happy. Meaning. Let's try to calculate. I had tried this yesterday at the end of the day, and I didn't really get that far. I'm not using speed anymore. This should be the speed. Last. Oh, next dot interp 2. We calculate the delta length. Let me just draw this. You're here. This one's there. This guy just got dropped. I'm going to do a different color. Go. That's your vector. Next t dot interp 2. I'm going to simplify this. A lot of copy pasted code. Current is not this. Next t dot interp start. Don't ask me why I used different names for these, like start and 2. So we have our current position. Start end. We have our speed, which this is hard coded, but this is like something set somewhere else that I should be pulling it from, but I'm not. Next. Start dot sub end. We'll get the length of that vector. That gives us this. Okay. Then we calculate the total based off of that. We take the length divided by the speed. The length divided by the speed, which is this. That tells us how many of these we need to do. Like that divides it up. I'm not gonna draw all those. You get the idea though. Dot dot dot. Length divided by the speed. I'm gonna take the ceiling of that. I don't know why, but I'm gonna. I multiply it by the fixed time. That's the fixed time step. And then that works. And I also want to. We'll do this now just to see what it looks like. Math. Oh boy. That didn't work. Oh, the time must calculated must be really long. Wait, when I do speed, what do I do? All right, let's see. Do I want to? I think speed shouldn't have this in it. Wait, unless I do, wait a second. Let's try that. Nope. The problem is like when I do this, when I use this one, it really looks, oops. Like it really looks good. Like I trail by like 6 things. Because if I take the latest set to 6, when I set it to 3, I trail by 3 things. Like this seems pretty good. The only downside is, like the rubber banding that happens inside of that. I'm not really sure how to smooth that out. That's why I was trying to use this like a flat speed to move at, or use the speed to calculate how long it should take me to get there. The obvious problem is this one, right? Where once you have a packet drop, you're going to interpolate this the same as all the rest, where you shouldn't be. Hmm. Man, this one's stumping me. I wonder what it looks like if I turn off. I feel like I'm not fully like appreciating or understanding something that's going on. Let me turn lag off. All right, no lag. Still does it a little bit. Oh, there's a jump. That could be just because of this though. Or let's do a print. Yeah, there's still little hitches where he like speeds up. It's got to be some hmm. Sorry, I'm thinking deeply. It's got to be something with like like what I think's happening just based off of looking at my printouts. What I think's happening is I think I have a bunch of Like these are like the fixed interpolation points, right? This is like the interpolation of 0. This is 1. And these are all the same length because you basically divide it up into segments. And then you have the next one. I'm going to make it green. And these butt together. And you divide it up into segments. I think what's happening is that if the if the duration of this, like you have this fixed dt, right, which is 16 milliseconds. So like let's say I'm doing a 16 millisecond interpolation on this length, and let's say this length is like 100 and I'm just gonna make it easy. I'm gonna make it like 165, right? Let's say we have like a few more. Well, now I'm gonna hit the 10th one at 160 total. I'm at the 10th one at 160 total, and there's gonna be like 5 milliseconds of slop time in here. And I think this needs to get carried over. What's up, Toga Games? Bang 3, bang 4, testing commands. I think the only one that should work is, or there's maybe a few actually. I don't know if Nightbot's working anymore. Yeah, Nightbot's not working. I have no commands. I don't know what happened with Nightbot. He used to work. Is Newbot working? My commands work. Got my own. Move how to get one. Move how to get to 1, and what 1 is every 16 millisecond. Yeah, the problem is like this I think what I need to do is I think I need to keep this slop time, and I need to add it into the next one. So the green one should technically start here. Make it rolling rather than calculated ahead. I'm setting up an interactive roleplay stream, just testing the code here. Okay. I don't know what that means exactly. The problem is that the rate at which I pull things out of my queue is the rate at which I pull things out of my queue is needs to be determined based off of how far, like how far back the queue is, or how far back my target tick delay is. I almost typed delay. So like these distant, or the time I'm pulling this out isn't really determined by the tick rate. Maybe it should be though. I guess if I did that, that would be fine. That would fix this problem. I wouldn't have to do the slop time thing. Or I take the slop time and I pop it over. Like I pop it over to the next one, which is what I typically do for I've done that before. I've done that for my game loops. I think let me try to do this 16 millisecond divider. That way it's running at a fixed time anyways. It'll always come to 0. Oops. Let me see. Can I make this divisible by 16? Average tick time. It should be actually. This should be divisible by 16. Let's see here. I guess it always does go to 1. I think that what I was saying was happening isn't actually happening. Um, I think I need to debug this more. I think I might take a little break here and call it a day. Sorry guys. Sorry, I thought for sure I was gonna fix this today. I was like I was so primed. Should add milliseconds to your logging to help. Numbers are lining up, but it's time. Oh, this isn't milliseconds. This is the like interpolated value. And it is being divided up properly. Like you can kind of tell. I'm glad your code works there, Toga. Good luck with your whatever you were doing. Yeah, but it isn't the right time. What do you mean by the right time? Like it seems like it's interpolating properly. From like what I expect to see is what I'm seeing, and I don't know why it's still zooming more. Like what's happening is left his timestamp. Oh, this. Oh, you're talking about this? Oh, gotcha. Yeah, this is just from the logging library that I'm using. It prints out a timestamp, and then it prints out a debug. I can show you what it looks like on a console. Like it's actually got colors and stuff like that. But just in Emacs, it doesn't render the colors properly. But what I see is what I expect to see. Where like well, I guess this doesn't really show it, does it? Because I need to be moving. We'll do that. Oh, I might be like extend the timestamp to include milliseconds so you make sure the interp is lining up with the correct part of the seconds. Yeah, I mean, it looks like the interp's lining up. I just think that um, sometimes the distance is more, and that's what's making it like go in and out in terms of speed. So I'm not really sure how to normalize that. But like what's happening is what I expect to have happen, which is like this is the position this is the start interpolation, stop interpolation. This is the actual position. So you're starting at the start point. Well, a little bit more because you're interpolating in the middle. But this goes all the way to 1 now. Now you should be at the destination point, and you are. And then the next one, you should be starting, your next tick should be somewhere different, and it is. I think when I compare the deltas between these, let's see. Like it's going down by 6. Well, 6 point, let me get a calculator. Or I'm gonna have to do this on other monitors because it's taking up too much screen. 726.4 minus 724.8. That's 1.6. And that was this change. Let's look at this one, 727.9 minus 726.4. That's 1.5. So like this one's maybe going a little slower. The distance was 1.5 changed here, and it was 1.6 here. I don't know. I'll have to look into this a little bit more. I need to go eat though. I've gotten too hungry. Now my brain stops working. But I appreciate everyone stopping by today. It was a good time, even though we didn't exactly complete what I wanted to complete. Exactly. Yeah, I need to walk away from it for a little bit, and because I worked on this yesterday too, but I didn't get as yeah. I don't know. This is kind of a tricky one. I don't know. The problem with this one is I don't have a way to like model it in my head. Really, I feel like I'm just like kind of being a little bit too willy-nilly with it. I feel like I'm trying to find like what's the closed form solution to this problem, and I just can't really figure it out. So I don't know. Once I have that, I think I'll be able to code it better. It's just about finding what that exactly is. Also, physics stuff can be weird too. So, and networking stuff is obviously really, really hard. But thanks everyone for popping in. It was a good time, and I will see you guys next time.